Hello everyone. In this lecture, we are going to discuss about the structures of spinels. Hello everyone. In this lecture, we are going to discuss about how to determine or how to predict the structures of spinel compounds. Spinel compounds are mixed metal oxides. Like one metal will be in 2 plus oxidation state while the other metal will be in 3 plus oxidation state. And the general formula can be written as AB2O4 or AOB2O3. In this case, the metal A is in plus 2 oxidation state while the metal B is in plus 3 oxidation state. The oxide anion is going to form a CCP or FCC lattice, and the CCP or FCC lattice will contain 4 octahedral voids and 8 tetrahedral voids. We are going to tell the structure of spinel by finding out which void occupies which ion or which cation. Like if A2 plus is occupied in octahedral void, there will be a different spinel, while if B2 minus occupies a octahedral void, in that case there will be a different spinel. To now I have defined what is spinel. Now let's discuss about types of spinel compounds. Spinel compounds can be of two types, normal spinel or inverse spinel. Basically, spinel compounds are mixed metal oxides which contains metal in 2 plus oxidation state or 3 plus oxidation states. So if we discuss about normal spinels, in that case the metal which is in 2 plus oxidation state is going to occupy 1/8 of tetrahedral voids. Basically, we have to study the structure. According to that, we are going to decide which kind of structure spinel is going to have, whether it's normal spinel or inverse spinel. So if A2 plus occupies 1/8 of tetrahedral voids, it's going to be normal spinel. And also, in this case, the B3 plus is going to occupy half of octahedral void. The example of normal spinels are MgAlO4, MgCr2O4, NiCr2O4, Mn3O4 and CO3O4. All of these are going to have a metal in plus 2 oxidation state as well as a metal in plus 3 oxidation state. The general formula can be written as AB2O4. While A is in 2 plus oxidation state, which is occupied in tetrahedral voids, B is in octahedral voids, so it's written in a separate bracket. Oxide ion is going to form the CCP or FCC lattice. After that, we are going to discuss about the inverse spinel. The general formula for inverse spinel is slightly different. Here it is written as BABO4. B is in 3 plus oxidation state and B is occupied in 1/4 of octahedral voids as well as 1/8 of tetrahedral voids. B is in 3 plus oxidation state and it is occupied in 1/4 of octahedral voids as well as 1/8 of tetrahedral voids. So this bracket is denoting the octahedral voids, and octahedral voids will contain A ion as well as B ion. The A2 plus will also be contained in octahedral voids. B is contained in octahedral as well as tetrahedral, while A2 plus is contained only in octahedral voids. Again, the O4 or the oxide ions are going to form CCP or FCC lattice. Inverse spinel will contain a structure just opposite of spinel structures. Like in this case, the A2 plus ions were occupied in tetrahedral voids, while in this case, the A2 plus ions are occupied in octahedral voids. That's how we can differentiate between them. Now, let's try to predict the structure of spinel. Now we are going to discuss the examples of inverse spinels. The examples of inverse spinels are CrFe2O4, Fe3O4, NiFe2O4, MgFe2O4 and NiAl2O4. In most of the examples, as you can see, Fe3 plus is there. So, if the spinel contains Fe3 plus ions, in that case, it must be inverse spinel. There is a direct way to predict for Fe3 plus ion. If Fe3 plus ion is present, the structure of spinel is going to be inverse spinel. Now what we are going to do is try to calculate the Cth Sc values so that we can predict the structure of spinel through calculations without using the actual structure. How to predict the structure of spinel? We are having a compound CO3O4. In this case, the oxide ion is forming the CCP or FCC lattice, while CO2 plus and CO3 plus ions are there. We have to calculate which ion will occupy which void. In the first step, we will try to calculate the CFSC value for CO2 plus in octahedral as well as tetrahedral void. And the same thing will be done for CO3 plus ion. For CO2 plus, we know if we look at electronic configuration, the CO2 plus must contain 7 electrons. Now the question arises why I am not pairing up the electrons. The oxide ion is a weak field ligand. That means the pairing will not happen. So if we try to calculate the CFSC value, the CFSC value will come as 0.8 delta naught. Now we will try to calculate for tetrahedral field. For tetrahedral field, the T2G and EG will have just opposite energies. It will come as minus 0.54 delta naught. That is quite less than CO2 plus in octahedral void. The CO3 plus in octahedral state is going to have a low spin configuration, and it does not depend on ligand field strength. It is just a case where CO3 plus usually shows, in case of H2O also you have seen that CO3 plus shows low spin configuration. So if we calculate the CFSC value for CO3 plus in octahedral field, that is going to come around minus 2.4 delta naught. If I try to calculate in tetrahedral field, it will act as weak field ligand only. So I have calculated the CFSC value for tetrahedral environment. Now you can see that for octahedral environment, the delta naught value was minus 2.4 delta naught. In case of CO3 plus octahedral environment, we are going to have value minus 2.4 delta naught. For CO3 plus in tetrahedral environment, minus 0.27 delta naught. CO3 plus in octahedral environment, minus 0.8 delta naught. And CO2 plus in tetrahedral environment, minus 0.54 delta naught. The value is highest in case of CO3 plus octahedral environment. So CO3 plus must reside inside a octahedral void. And if CO3 plus is residing inside octahedral void, you can conclude that it will be a normal spinel. That's how we are going to calculate. Now I am going to take one more example, and in this example you just have to calculate by yourself. I am just writing down the answers, you can match. The example is Mn3O4. You have to calculate whether it will be a normal spinel or inverse spinel. You can pause the video now and try to calculate. Then after this, you can match your answer. So for this case, you can see that CFSC value for Mn3 plus in octahedral state is highest. So it will be normal spinel again. You can calculate in the same way for inverse spinel. You can try one more example, Fe3O4. In this case, the Fe3 plus is going to have highest CFSC value in tetrahedral state. That means it will be inverse spinel. Please like and share this videos and subscribe the channel.